In this video, we're going to talk about section 1.3 in the language of relations and functions. So first, let's describe what relations is. If we have two sets A and B, a relation R from A to V is going to be a subset of the Cartesian products A times B. So essentially, if we have an ordered pair XY that belongs to the relationships, then we write that X is related to Y. A, in this case, is going to be called the domain, and B is going to be called the codomain. A relation is just going to be a set of ordered pairs. Now, to give an example of that, let's consider the set A equals 1, 2, 3, and B equals the set of A, B, C. So there's some valid relations from A to B. So for example, we can have relation 1, 1A, 2B, 3C, R2, 1A, 1B, 2A, R3 can be 2C, just one pair, or we can even have the empty relationship, which is the empty set. Notice that for R1, we can write that 1 is related to A, but 1 is not related to B. Okay? We can see that here because essentially there's not a pair 1B. Okay? In the same fashion, 2 is not related to C, but 2 is related to B. This dash should be crossing entirely the R1. Now, we can do visual representations of a relationship. We draw the domain A in one region, and we draw the codomain B in another region, and we draw an arrow going from X to Y for any order pair XY that belongs to the relationship. So for example, if A is 1, 2, 3, and B is AB, we can draw the relationship 1A, 2A, and 3B by this diagram. Y relates to A, 2 relates to A, 3 relates to B. Now, one natural consequence of the relationship is going to be the functions. So a function is now going to be a relation from the set A to the set B that satisfy a couple of conditions. The first one is that every element of A is related to something in B, and that each element of A is related to exactly one element in B. We didn't have this before. We just have whatever in the relationships, but now for the functions, we're getting very specific conditions. So in simple terms, every input gets exactly one output. No input is going to be left out, and no input maps to multiple outputs. Now, if f is a function from A to V, we describe this as f from the domain A towards B, or f is a function from A to B. We also can represent this as f of x is equals y, which means the xy pair belongs to the function f. In terminology, f of x is called the value of f at x, or the image of x under f, or the output corresponded to the input x under f. We use, of course, arrow diagrams to relate relationships. So a function is going to work out in a similar way. We have the relationship is a function if and only if every element in the domain has exactly one arrow leaving it. No element can have 0 arrows, and no element can have 2 or more arrows. So for example, here, this is a function that covers those 3 ideas, and this is not a function because 1 is going to multiple places. Now, another example, consider the set of A equals 1, 2, 3, and B, A, B, C. Now, we want to consider is F the set of the pairs 1a, 2b, and 3c a function? Well, if you consider every element of A has exactly one arrow. 1 is going to A, 2 is going to B, and 3 is going to C. So yes, this is a function. And we can write f of 1 is A, f of 2 is B, and f of 3 is C. Now, on the opposition, or another example really would be consider 1, 2, 3, consider B equals A, B, C. If we have the function 1a, 2a, 3a, is this a function? And the answer is yes. Although every element is mapping to the same element in B, that doesn't matter because we have an arrow for each element and each input has one output. So it's okay for different inputs to have the same output. What's not okay is one input having multiple outputs. We see that here, that example. For example, here, consider A equals 1 to 3 and B equals A, B, C. We want to know if 1A to 2B is a function. And that's not going to be a function because it violates the fact that 3 has no output. So there's one element in the domain that has no image, and that's violating property 1 that we previously defined. This is another example here of not a function. Notice that 1 is going to both A and B. So the element A is related to both A and B. So one input has 2 arrows. One input has 2 elements on the other side. So this violates property 2, the function definition, and it doesn't work out as a function. Now, some familiar functions are relations. For example, if you have f of x equals x squared, this is just the relationship f of the ordered pairs x squared with x that belongs to R. Every real number here, x maps exactly to one value, x squared. So this is a function from R to R, and we have that f of 2 is 4, f of minus 2 is 4, etc. Notice that the fact that f of 2 is equals f of minus 2 is going to be fine because different inputs can have the same output again. Now, consider the circle relation. 2 points belong to the circle if x squared plus y squared is equals 1. Is this a function? Well, not really. The problem is, if you consider 0, the point 0, 1 belongs to the circle, and 0 minus 1 belongs to the circle. But this means that one input, x equals 0, has 2 outputs, which is 1 and minus 1. So this will not be a function. This represents a circle, but not every vertical line is going to intersect vertically just once. And that needs to happen for something to be a function. So in summary, we have relations, that is any just set of ordered pairs from the Cartesian products. We have functions, which are special relationships where every input has exactly one output. And f of x equals y means that the ordered pair xy belongs to the functions. We have the arrow diagram test, which is every domain element needs exactly one arrow in the other direction. Multiple inputs, same outputs is okay, but one input and multiple output is not okay. Okay? So be careful with the domain versus codomain. The domain is the set that you're mapping from, the inputs, and the codomain is the set that you're mapping to, the possible outputs. So here in f1 to 3 to a, b, c, d, this is giving me the function 1b, 2a, and 3b. Notice that the domain is 1 to 3. The codomain is a, b, c, d. The outputs that are used is a, b, which is fine. It's not all the codomain, but we don't have to use everything in the codomain. So this is fine. But this is indeed a function because every element of the input has one output. Okay, let's check this more in details in the exercises.